The architectures for interaction programming presented here have been applied for many years and will probably be applied in many technologies, many applications, many frameworks for that matter, even outside the web environment that we work with today. Given two representations of the same data, where should we keep the data? Unexperienced programmers tend to keep the data in both representations, and then there is a lot of notification between the two. People came up with the observer-observable pattern, or short observer. In this pattern, we keep the data in a third actor, which is called the data model. It keeps abstract data, no graphics. The two representations then add themselves as observer, and that's a subscription, very similar to an event listener. And then when one of them changes the model will notify both of them, so they can update. So the model is called the observable. The representations are called observers. You can add many observers at any time. In JavaScript, implementing observer is simply a matter of sending out a function, like we also did for add event listeners. And the observable keeps an array of these functions, and whenever there is a notification, it just calls each function in the array. In Java, for example, there are standard libraries for this. As you see, the Alice and Bob situation is getting more complex. We have input boxes or any kind of buttons or any kind of HTML widgets that fire different types of events and add event listener or subscription. We have the custom component where a subscription is done with by setting a prop, and then there are higher level events. And then we have observable, the model. The observer subscribes to it by saying, for example, add observer, passing a callback, and then the notifications will come in the form of calling the function, often without any parameter, just saying something has changed and not say what. That's because the recent trend in interaction programming is to simply re-render everything, and then it's not so important what has changed. The data has changed, we re-render the components, then we don't need any payload here. Once we have done this separation, we have separated the observable from the data representations. The question is who should do the other work? So this graphical representation now need to read the data from the model, represent the data somehow, detect user events, interpret those events, modify the model, and when the model notifies, read the data again and re-render. One proposed separation here is the separation where everything that has to do with data representation in some DOM HTML widgets, and then getting DOM events, basic level events from these widgets, is done by one actor, and the other actor deals with the model, reads data from the model, changes the model, gets notified by the model, re-renders everything. This actor that does a lot of graphics and gets low-level events is called the view, and the other actor that deals with the model is called the presenter. So in Model-View-Presenter, in the little application that we're designing here, we have a guest number presenter which adds itself as observer, reads data from the model, converts it to whatever format its view wants, and renders. You see that here is the number of guests, but the guest number presenter needs to make a conversion because this one doesn't know anything about guests, it just knows about numbers. So then at least the name of the prop has to change from guests to numbers. Then there is another presenter which also adds itself as observer, renders. Here we know more about guests, so this view is made specifically for this application. We render the view, and then there's a custom event coming. We set the number of guests in the model notifies both presenters, and then both presenters re-render and update in the DOM their views. So as you see, the presenter is a mediator between model and view. And you can, for example, keep the same views, change the model completely, like go from a simple JavaScript class model to a Redux model. Or you can keep the views. Having Redux, you can generate automatically the presenters using, for example, React Redux. So you can see the versatility of this architecture. Also in the lab, you keep the views and you change the presenters for React and for Vue while the model stays the same. We can make a presenter for the number editor, which adapts it to the dinner model. We do one function, which basically returns a number editor with the props read from the model, that is, reading the number of guests from the model, and the custom event prop, which changes the model, given an integer such number of guests. We do an initial rendering, and we then add an observer. The observer does precisely what we did in the interaction lecture when we wanted to do update by re-rendering. There is a re-render, there is a replace child, or then we update our reference to the view, and this returns the view. So this is going to be rendered and re-rendered all the time in the tree when the model notifies. And then when we test, we instantiate the dinner model and we append to the body of the document one presenter and the other presenter. What the difference between the previous scenario here is that the model has an application logic, has a policy. So for example, it will not allow 0 guests or negative, and then we will not be able to go lower from 1 in this number editor, even if the number editor doesn't know about that. The presenter might need, though, in its adaptation work to treat such cases. What happens when the model refuses to update the number? Maybe we want to display something else, and so on.
Here we have our number editor used as a view in a model view presenter architecture. What you see is that the model doesn't allow us to reduce the number of guests under 1 because of its application logic. We see them as errors in the console. What the model view presenter allows us to easily do is to simply add one more presenter and one more, and all of them will work in concert because they all watch the same model.
As you see, presenters own the views, and I've just implemented the presenter as a component, but they should not render much user interface. And one presenter can combine many views. But only one presenter should know about the view. So views are a bit lower down in the hierarchy in this approach because presenters are basically commanding over them. So data, like the number, travels down from presenter to view. The custom events notification travel up from view to presenter. So we have props down and events up. And this technique you can apply even if we don't necessarily think of model view presenter. Presenter components are often called also containers because they contain the view. And views are known as presentational components, which might be confusing. This is a React type of terminology, which they also gave up recently with custom hooks and such. Model view controller we present here mostly for historical reasons. Here we have a model, we have a controller which instantiates a view, and then it also adds itself as an event listener, adds many event listeners to the view. The view adds itself as an observer to the model. And then there is an event coming from the view to the controller interprets it, modifies the model notifies, the view updates. So as you see here, we have a bit of a circle. Event from the view to the controller, changing the model, notification, and then it can go on several times. Now, if we compare model view presenter to model view controller, the presenter does a bit of the controller job because it changes the model, but also some parts of the model view presenter view do a bit of the controller job because they listen to low-level events. Also, model view controller is circular, as you see here. The process goes in a circle, while model view presenter is linear. Things go from model to presenter to view, custom event from view to presenter to model. Because most component-oriented architecture requires some sort of hierarchy, it's very hard to keep such a circle in that hierarchy. So these linear relationships from parent to children are preferred. So that's why model view presenter is very much used today, knowingly or unknowingly. But Model View Controller has a very important role in the history of computing. It's been invented when the first graphical user interfaces with overlapping windows and menus and pointers were invented, and this is a historic such interface in the 1970s, the Xerox Star. And then engineers from here and ideas from here traveled to both Apple and Microsoft, and then the Macintosh and the Windows environments came up. Another thing that you might hear about is the Model-View-ViewModel. So the view model in this architecture is pretty similar to a presenter. The difference is that there is data binding between the view and the presenter. So the view might look like this. It says summary for, and then it uses data from the presenter, and then the text continues. So this is called one-way binding. There is something in the presenter that keeps updating in the view, and the rest of the view stays static. The other step here is that this can go both ways. So if we have an input instead of a display of a number, then we say here vModel equals number, which means that whenever this input is going to change, we change things in the view model, which might then change things in the basic model. Or whenever the thing in the view model changes, we will update here. So this is called two-way binding, from view to view model and from view model to view. The view technology that we work with in the course is nowadays simply translating these strings into JSX. Templates and data binding were really big in frameworks in the past, like Angular and Vue. And then JSX has basically superseded that because it's much more powerful. We would tend to believe that the model is simply some abstract data, some object in some programming language. But there are many evolutions there as well. For example, ReactiveX is a big combination of observables. So everything they see is an observable. The model itself, but also remote data access, and even DOM events. So basically the whole philosophy around this is to combine observables to get a very, very well-connected model, and then to just implement simple presenters and views. This is used a lot in Angular. The other trend is that for large applications and with lots of programmers, managing application state can become really cumbersome. You need to have lots of meetings to decide what you're going to have in the model and in what way and so on. So technologies to address that, I would call them state managers like Flux and Redux, which were invented by React. Actually, React invented these things before JSX, for example, and Vuex, which is the view correspondent. What is interesting is that the frameworks that we work with work at presenter and view level, and all of these, Redux, Vuex, RxJS, they work mostly at the abstract level. So you can use any of them with any framework.